Hello everyone, how to solve this problem for the values of k. If we have k divided by 5 multiplied by k divided by 5 is equals to 5 over k times 5 over k. So here we need to solve this problem for all the values of k. So here we need to find all the roots of this equation, and now we solve this problem from this very easy method. I hope so you like this method, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And now we move toward the solution of this problem. So here first you see that these are the two fractional terms are multiplied by each other. So it means that we multiply this k with this k, and we multiply 5 with this 5. And when we multiply k times k, it will be written as k square divided by this is 5 multiplied by 5 is written as 5 square. In the same pattern, we multiply this 5 with 5 and we multiply this k with k, and it will be written as this is 5 times 5 becomes 5 square divided by k times k becomes here k square. And further in the next step here we need to cross multiply the terms, and we move this k square to the left hand side and we move this 5 square to the right hand side. And after cross multiplication of the terms, it will be written as this is k square multiplied by k square becomes k to the power of 4 is equals to this is 5 square multiplied by 5 square becomes 5 to the power of 4. And now you see here this equation will becomes in fourth order equation. It means that this equation has 4 roots, so that now we need to find all that 4 roots of this equation. So here we move this 5 to the power of 4 into the left hand side, and it will be written as k to the power of 4 minus 5 to the power of 4, and this whole equation is equals to 0. And now here further in the next step we need little bit more simplifications, and it will be written as this is k to the power of 4, and it will be written as k square and its whole square minus this is 5 to the power of 4, and it will be written as 5 square and its whole square, and this is equals to 0. And further in the next step we need more simplification, but here we use the nice algebraic formula. You know about that. If we have a square minus b square is equals to a minus b times of a plus b. According to this formula, we write our above equation as the base of this term is our a and the base of this term is our b. So after applying this formula, our above equation is written as after using this formula, it will becomes here this is a minus b, the value of a is k square minus the value of b is 5 square into again we have a plus b, the value of a is k square plus the value of b is 5 square, and this whole equation is equals to 0. And now we divide this equation into the two cases. The first case is we write k square minus 5 square equals to 0, and the second case is we write k square plus 5 square equals to 0. And now here first we need to solve our first case, and in this case we again apply this nice algebraic formula. So according to this formula we write this term as k minus 5 times of k plus 5, and this whole equation is equals to 0. And now here further in the next step we again divide this equation into the two cases. The first case is we write k minus 5 equals to 0, and the second case is we write k plus 5 equals to 0. From here we easily get the value of k is equals to 5. So this is the first real root of the given equation, and from here we easily get the value of k is equals to minus 5, and this is the second root of the given equation. And further in the next step we need more simplifications here, and now we move towards our second case. And in this case we move this plus 5 square to the right hand side, and it will becomes k square is equals to minus 5 square. And here our target is to get the values of k. So for this we need to remove this square sign. So that's why we need to take a square root on both of the sides. And now you see here this 2 and this square root are gone, and we get here k is equals to, here you see that when we apply a square root on both of the sides, we will be right here plus minus sign on any one of the sides, so we write into the right hand side. Further, we break this square root sign separately on negative term and 5 square. So when we break square root, it will become square root of 5 square multiplied by square root of -1. And now here in the next step, we need more simplifications, and it will be written as k is equals to plus minus this 2 and this square root are gone, and we get here 5. This -1 square root, and we know about that -1 square root is equals to iota. So these are the other two complex roots of the given equation. So because here our equation is fourth order equation, so we obtain the four roots of the given equation are in which two roots are real, and that is k equals to plus minus 5, and the other two complex roots are plus minus 5 iota. So these are the four roots of the given equation which we get here in this method. And now here in the next step, we need to verify that is these roots are solution of the given equation, or is these roots be the extraneous root. So for verification, we need to copy down given question statement here. It is k divided by 5 multiplied by k divided by 5 equals to 5 over k multiplied by 5 over k. So before verification of these roots, first we write our given question statement into the simplified form, and we write this term as k square multiplied by 5 square, and we write this term as 5 square multiplied by k square. And now we are ready to substitute the values of k, or verification of k. So here in this side we will be verify k equals to plus minus 5, and in this side we will be verify k is equals to plus minus 5 iota. So here first we substitute this value into the given question statement, and it will be written as plus minus 5 whole square divided by 5 square is equals to 5 square divided by k square, and when we put this value it will becomes plus minus 5 square. This is the first case, and here we can substitute these values, and when you put these values it will be written as plus minus 5 iota and its whole square divided by 5 square is equals to 5 square divided by k square. The value of k is plus minus 5 iota and its whole square. Now here in the next step, first we simplify over this case, and here we verify these values. You know that when we apply a square on positive or negative term, it will always get the positive answer. So here we get this plus minus 5 square becomes 5 square over 5 square, and in the same pattern this plus minus 5 square is also becomes here 5 square. So these and these are gone, these and these are gone, and we easily get 1 is equals to 1. So this shows that both of the sides are equal when we choose k equals to plus minus 5. And now here we verify these values. Again you see that plus minus square becomes positive value, and iota square becomes iota square divided by 5 square. Okay, in the same pattern we have this is 5 square divided by plus minus square becomes positive, and this is 5 square and iota square. This 5 square, this 5 square are gone, this 5 square, this 5 square are also gone, and we get here iota square equals to minus 1, and this iota square is also equals to minus 1. This shows that again both of the sides are equal. It means that all the roots of the given equation are satisfied over given question statement. This is the final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.